Hello guys. Hello. Hey guys. So today we are going to start our another chapter, which is again very crucial chapter. This is linear equations in two variables. So we're just waiting for a couple of more minutes for people to join in, and then we'll start. Okay, so let's start. Okay, so we are going to discuss in this session linear equations. So the agenda is to discuss linear equations. And linear equations, especially in two variables. And after that, what we'll try to do is we'll also see how to solve linear equations. Solving linear equations. Then we also talk about consistency. Consistency of solutions, or right, and then towards the end we'll also see word problems. And for autonomous syllabus specifics we'll discuss towards the end. Okay, so let us start. So basically, the definition, will quickly run through the definitions and all the basic concepts, and then we'll try to solve as many problems as possible. So a pair of linear equations in two variables x and y can be represented algebraically as follows: a1x plus b1y plus c1 equals to 0, and a2x plus b2y plus c2 equals to 0, where a1, a2, b1, b2, and c1, c2 are real numbers such that, yeah, you have to see that a1 and e2 both together cannot be 0. So a1 is not equal to 0. So basically both together cannot be 0. a1 and b1 not equal to 0 simultaneously cannot be possible, right? So hence all of them together cannot be 0. Hence this particular expression has been given. Okay, so this is my definition of linear equations. Now, next is graphically or geometrically pair of linear equation in two variables represent a pair of straight lines. Okay, so we know, and let me just draw a graph. So hence, how does linear equation look like in a graph? Okay, so let's say this is x, this is y. Okay, so linear equation will be of this form, where this is a1x plus b1y plus c1 equals to 0. This is not equal to, this is plus here. Okay, so a2x plus b2y plus c2 equals to 0. So another equation could be something like this. So uh, right? So this one is, let's say this one is a2x plus b2y plus c2 equals to 0. Okay, and this point of intersection, this is the point of intersection. Okay, this point here is the point of intersection, right? So hence we say that these two lines are intersecting. This is the first condition, and there will be questions around that. You know this, that those two lines are intersecting. What is the criteria? Criteria is a1 upon a2. That means coefficient of x in the first equation divided by coefficient of x in the second equation must not be equal to coefficient of y in the first equation. And sorry, this is not, yeah. So this is b1 by b2. Yeah. So this is the condition for unique solution or one solution, one pair of solution. That is, pair of solution means what? You will get x and y. One set of x and y you will get, right? If they are parallel, the other condition could be if they are parallel. Let's say this is parallel. Okay, so parallel lines. So this is x, this is y, and again, if this is equation number 1, let's say this is a1x plus b2y plus c, sorry, not b2, b1y plus c1 equals to 0, and this line is a2x plus b2y parallel by a2 is equal to b1 by b2 c2. Sorry, for parallel lines this must not be equal. So a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Okay, so this is for parallel lines, and for coincident, this is case number 1, this is case number 2, and case number 3 is this coincident. So coincidence is this. That means all the ratio must be equal. So for coincident or overlapping coincident lines. For coincident lines, the ratio should be all equal. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Right? This is our linear equation, consistency criteria. Okay, so okay, now, so a pair of linear equations in two variables can be solved by two methods. What are two methods? Graphical method. One is graphical method, and another is algebraic method, right? And in algebraic method, you also know there are three processes. One is called substitution. Then there is something called elimination. And third is cross multiplication. Right? So we'll see all these methods one by one, right? And please be very, very careful in linear equations. If the question categorically asks you to use one particular method, then do not solve the question using some other method. So hence, read the question carefully. Many a times they would mention which particular method they are asking for. You can use your other methods to check whether the solution which you have arrived at is correct or not. Okay. So to solve a pair of linear equation in two variables by graphical method, we first draw the lines represented by them. If the pair of lines intersect at a point, then we say that the pair is consistent and the coordinates of the point is the unique solution. Now, if the pair of lines are parallel, then the pair has no solution and is called inconsistent pair of equation. It's called inconsistent. So be careful about these keywords they will be used. They will be using. So consistent, then inconsistent, and then if the pair of coincident lines, then it has infinitely many solutions. So there are three things. Each point on the line being one solution. In this case, we say that the pair of linear equations is consistent with infinitely many solutions. So yes, what all? One is you have unique pair of solution or unique solution. This is, then there are infinitely many solution, infinitely many, and then third is no solution. In these cases, it's called consistent. The system is consistent, consistent, consistent. And in this case, it is called inconsistent. Okay, so you must remember these, because invariably last year also in 2018 there has been one question where they had asked a question on consistency of the two equations. So let's start. Yeah, so this is algebraically. Let's understand how to solve. Let's say in this case, if two equations are given, so let us say a1x plus b1y plus c1 equals to 0 is given, and then a2x plus b2y plus c2 is equal to 0 given. Excuse me. So let us see through GeoGebra. Okay, so here is the two equations. So let's say y equals to 3x plus 2 here, and y is equal to 2x minus 5. These two equations are given. So what you need to do is, you need to first of all plot the graph of first equation, then plot the graph of second equation, and wherever they are intersecting. For example, this is the point here. So if you see this point is the point of intersection. A minus 7 minus 19 is the solution to this pair of system of equations. So how do you plot? I will just briefly give you a process. So let's say you had 2x plus 3y plus 1 equals 0, and you had 3x minus 2y plus 2 equals 0. Then you convert, or let's say transform them in such a way that it is in y equals to mx plus c form. So how do I write this? I can write this as 3y equals negative 2x negative 1, and y hence is equal to minus 2 upon 3x minus 1 upon 3. Correct? Then what you need to do is, you just simply need to put random values of x. Usually we start from 0, 1, 2 and all that, and some negative 1 and negative 2 and all that, and then plot at least 2 points. 2 points are good enough to plot a linear equation. So let's say if you get 2 points x and y. So let's say if you put x equals to 0 here, what will you get? You will get y equals negative 1 by 3. So put that. So hence first ordered pair is 0 and minus 1 by 3. Okay. Right. And simply if you put x equals to 1, then y. So when x equals to 1, then y is equal to minus 2 by 3 minus 1 by 3 is minus 1. Okay. So another point is 1 comma minus 1. So what next? You simply need to plot x and y in a graph paper. They will give you a graph paper, and then what do you need to do? Plot 0 comma 1 point minus 1.3. I'm not doing it with scale. You guys, when you do it, you have to do it using scale and graph paper. So 0 comma minus 1 by 3 will be, this is x equals to 0, and this is, let's say, minus 1 by 3. Okay, so 0 comma, this is x equals to 0 and y minus 1 by 3, and second point 1 comma minus 1 will be 1, and maybe this is minus 1. Let's say this is 1 and this is minus 1, so this point, so hence you have to draw it freehand, and using a scale you should do. So you will get this line. Similarly, in this case, you will get positive slope value. So hence it is nothing but y equals, here I'm writing in one step itself. So this is 3 by 2x plus 1. Okay, so this line is somewhere like that. Okay, so this is, so hence this line, and this was the line initially. So hence whatever is this is the point. So hence you have to draw a perpendicular from here. So basically you have to, if you see, this perpendiculars have to be dropped from here. So this is x and this is y, right? So hence whatever is the x and y coordinate here, you'll have to write that as a solution. So this is graphical solution. Okay, fair enough. Now let's go to the algebraic form. So there are three: substitution, elimination, and cross multiplication method. And I think we should be taking examples to explain these in detail. So just let me take an example so that we can solve um, one question, so that all the three methods are covered. Yes. Okay. So let me take a question 2x minus y minus 3. So the question is, so let us go down to our, yeah. So let me just explain it here. Okay. So we are going to take one question to explain all the three methods. So let's say we have to solve, the question is solve this pair. What pair? 2x minus y, 2x minus y minus 3 equals 0, and 4x plus y minus 3 equals 0. So 2x minus y minus 3 equals to 0, 4x plus y minus 3 equals to 0, and we'll see each method one by one. Now clearly this is of the form of a1x plus b1y plus c1 equals 0, and the second one is a2x plus b2y plus c2 equals 0, and clearly a1 is equal to 2, b1 is equal to -1, and c1 equals -3. Then a2 equals 4 here, b equals 1, and c2 equals -3 again. Okay. Right. Now let's us first take a substitution. What is substitution? You have to first express one of the variables in the form of other variables, and you can use any one of the variables, but usually we try to avoid fractions. So hence, instead of expressing x in the form of y, I would have gone for expressing y in terms of x, because that would have eliminated any appearance of fractions in the equation. So if you see, it's always a good practice to keep numbering the equations and then mention the equation in terms of numbers. So you can say from equation 1, you can say y equals, be very, very careful with sign, guys. So if you're writing y, that means y is going to the right hand side here. So y is equal to 2x minus 3. It's always a good practice to go a little slow here, because if you miss any sign, then the entire equation is going to be wrong. So hence, y equals 2x minus 3, and now this is 3. This is equation number 3. So you will write using 2 and 3, using 2 and 3. Okay, using 2 and 3. What can you say? You can say put y back into the second equation. So 4x plus y. Now I can substitute y for this thing which we just found out. So let us say 2x minus 3 here minus 3 here equals to 0, and then it is 6x minus 6 equals to 0, which becomes 6x equals to 6. So hence x equals 1. Right? X equals to 1. So if x equals to 1, then clearly what is y? Y, I will use equation 3. So from 3, y equals 2 times 1 minus 3, which is nothing but -1. Correct? Let's check them. Let's check it whether it is correct or not. So equation was 2x minus y minus 3 equals 0. So if you put x equals to 1, you will get 2 here, and then y is equal to -1. So minus 1 is plus 1. So this is 3 minus 3, which is 0. So hence this particular equation and second equation is also satisfied. If you check 4 into 1, -1 minus 3 equals to 0. So both x equals to 1 and y is equal to -1 is the correct solution. So we just check. This is called substitution. What did we do? We express one of the variables in terms of the other, and then okay, so you use one in terms of the other, and then substitute in the second equation, and then find the other variable. Okay. Second is elimination. How do you use elimination? Same set of equations I'll use. Equation is 2x minus y minus 3 equals 0. And second one is 4x plus y minus 3 equals to 0. This is equation number 1. This is equation number 2. So what do? We need to eliminate. So elimination, as the name suggests, you'll have to eliminate one of the variables. Either you can eliminate x or you can eliminate y. And how do you eliminate? We manipulate the coefficients of x and y so that the coefficient of x or y becomes same or with opposite sign, right? And then either depending upon the sign of the coefficient, we'll add or subtract. So I'll do both case in this case. So let us say I want to eliminate y. So if you see, if you simply add the two equation, adding two equation means add LHS to LHS, add RHS to RHS. So if you simply add all of them, so 2x plus 4x will give 6x, minus y plus y will give you 0, and minus 3 is minus 6 equals 0. So very simply, x comes out to be 6 upon 6, which is 1. Okay. Now what you can do is you can deploy x back into the any of these equations and find the value of 1. So for example, if I putting x equals to 1, putting x equals to 1 in, let's say, 1. So it will become 2 into 1 minus y minus 3 equals 0. So hence y is clearly 1. See, if you see, this is matching with our previous solution. Whatever we found out here, if you see x equals to 1, and yeah, so this is the solution we obtained in the previous case through substitution. The same thing we are getting through elimination as well, right? Another way of, let's say in this case we use substitution also, but we can use direct elimination here also. How? So let us say I have to eliminate x. So I have to eliminate x. So what I'll do is I'll multiply the first equation. So let me write it once again. So 2x minus y minus 3 equals 0. And 4x plus y minus 3 equals 0. Now I'm saying I have to eliminate x. So how do you eliminate x? First try to match the coefficient. Okay, match the coefficient. So if you see, coefficient of x here is 2 and here is 4. So if I multiply this equation by 2, they will match. Okay, so 2 into 1 will give me what? 4x minus 2y minus 6 equals 0. Let us say this is equation number 3. And you write second equation once again, 4x plus y minus 3 equals 0. So this is equation number 2. Now what do? You subtract the second equation from the first one. So hence this will become negative, this will become negative, this will become positive, and hence if you add now, you will get 0 minus 3y is minus 3 equals 0. So from here y equals to negative 1. Yeah. And again, you put back y equals to minus 1 in any of the equations. Let's say putting y equals to putting y equals negative 1 in, let's say, equation number 1. What will you get? 2x minus 1 minus 3 equals 0. So which is nothing but 2x minus 2 equals 0. So x equals 1. So this is the solution. So we saw both the ways, right? So what all did we see so far? We saw first is substitution. You know what to do. Again, I'm telling you, please be very careful. If they have mentioned any particular method, do not use any other method. Second is elimination. So these two we learned. And the third one which we are going to learn is the cross multiplication. Yeah. So the third one is cross multiplication. Now in cross multiplication, there are few things to be taken care of. Yeah. In which form you are writing the equation is also important, because if you miss the, one particular form has one particular format of form, as in, the pattern in which you have to remember the formula. Okay. So I prefer that formula where all the all the terms are on one side. Okay, what do I mean? I mean, let us take the same two equations. So the two equations are, again, if you see, 2x minus y minus 3 equals to 0. So this is one is 2x minus y minus 3 equals 0, and the other one was 4x plus y minus 3 equals to 0. Now here, if you see, there is nothing on the right hand side, only 0, right? Another way of writing this could be 2x minus y equals 3, and 4x plus y equals 3. So make sure that you follow one, because if you have this particular format ready, then you have another yeah. Yeah, just a minute, guys. There's some issue. Yes. So yeah. So what I was saying is, you have to have one particular format. Yeah. So let's say if you're using this format, this left hand side, okay, then you have to have one type of formula. If you are having this particular type format, then another type of formula. So hence I generally use this one, and hence in this case, what will be the formula to be used? So I write it like this. So make sure that all of them are in the same side and only 0 is there on the, okay. So hence the formula goes like this: x upon, you have to write b1 b2, and then you have to write c1 c2, and then this equals to y upon c1 c2, and then a1 a2, and this is equal to 1 upon a1 a2, and then b1 b2. And then you have to multiply top left to bottom right first. Top left bottom right always. Top left bottom right always first. Okay, and then you can write this as x upon top left bottom right, right? So it will go in this direction. Top left to bottom right, you have to multiply. So you will get b1 c2 minus b2 c1, and this is equal to y, again same thing, top left bottom right. So c1 a2 minus c2 a1, and this is equal to 1 upon a1 b2 minus a2 b1. Okay, so hence here what will happen? This implies x will be equal to, simply, if you equate this part with this part, all three are equal, so I can say x equals to b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. And similarly, y is equal to, you have to now equate these two, this to this, right? So hence you will get y is equal to c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. Right? So let us deploy the formula and see whether we are getting the correct answer or not. So let us say what was p1 and all that. So let us first find out a1 b1 and all that. Okay, let us rewrite it again. So the two equations were this. So clearly our a1 is equal to 2, and b1 equals to -1, and c1 equals to -3. A2 similarly equals to 4, b2 is equal to 1, and c2 equals to -3. right? So let us deploy these values here. X equals to now B1 C2. So negative 1 into C2, which is negative 3, then minus B2, which is 1, into C1, which is negative 3, divided by A1 B2. So 2 into 1. So 2 into 1 minus A2 B1. So A2 is 4 into B1 is negative 1. So hence if you see, this is nothing but 3 plus 3 divided by 2 minus 2 plus 4, which is nothing but 1. And in this case, C1 A2. So C1 is negative 3 and A2 was 4. So this into 4 minus C2 is negative 3 into A1, which is 2, divided by same thing, 2 into 1 minus 4 into negative 1. And if you see, this comes out to be minus 12 plus 6 divided by 6, which is nothing but negative 1. So if you see, in all the three cases, we got the right answer, isn't it? X equals to 1 and y equals to negative 1. In all the three cases. What cases? In substitution, in elimination, and third is cross multiplication. Okay. Just a minute, guys. Yeah. Okay. So now we will come back to our this thing solution of the other solutions. Sorry, the other important topics. So again, we are coming back to the consistency part of it. So if you see, there are two equations, a1x and plus b1y plus c1 equals to 0, and a2x plus b2y plus c2 equals to 0, our standard form. And then we say that if a1 by a2 is not equal to b1 by b2, then the pair of linear equation is consistent. Please remember, inequality of the first two ratio is consistency. That means there you will get one pair of solution. Here in the second case, the pair of linear equation is inconsistent when a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. Okay, next, and the third is a1 by a2 by a2 is equal to b1 by b2 is equal to c1 by c2. In this case, these lines are parallel lines, so you can remember like that. So crisscross, that is intersecting line, means not equal to, right? And then parallel line is the second and the third ratios should not be equal, and coincident line are when all the ratios are equal. Okay, so we'll be seeing these applications a little later. Yeah. Now here is the question. Now let us start solving questions. So the question is, represent the following pair of equations graphically and write the coordinates or points where the lines intersect y-axis. Okay, so we will use a software here. Usually you know how to do it if you have a graph paper. So let me just take this graph paper. Okay. So let us say this is like a graph paper for you. Now let us first write down the two x plus 3y is equal to 6 and 2x minus 3y is equal to 12. X plus 3y is equal to 6. So hence I have x plus, and the other one is 2x minus 3y equals to 12. So this is 2x These are the two equations I have to solve graphically. So if you see, there is a kind of graph paper already here, so we'll use that, and that's how you have to do there. Also, I'm not using a scale because I'm using a tab. So let us say, first of all, draw a graph paper, or let's say X and Y, right? So my drawing will be a little rough. So this is X, this is Y, okay, and this is negative X. You have to do full negative X and negative Y as much as the question demands. Now, what is it? So X plus 3Y is equal to 6. So X plus 3Y is equal to 6. This is the first, right? So hence, let us first plot the first equation. So hence, if you see, the first equation is X is equal to 6 minus 3Y. This is one. So let us plot, or let us find out the values of X and Y. 6 minus 3Y, right? No. So hence, let us say this is X and this is Y. So when Y equals to 0, you should take one of them as 0, then it becomes easier to find out. So when Y equals to 0, X equals to 6. And when X equals to 0, you'll see, if you put X equals to 0, you'll get Y is equal to 2. Right? So when Y is equal to 0, X equals to 6. And when X equals to 0, Y is equal to 6 by 3, that is 2. So now you can easily plot this. So first point is 6, 0. So 1, 2, 3, 4, 5, 6. This is 6, 0. So let me use this color. So this is my first point, 6, 0. You write it 6, 0. And then 0, 2 will be somewhere here, 0, 2. Okay, then what you need to do? Right? So hence, what you need to do is, you need to just free with a scale, we join these. So this is the first equation. Now second equation is 2x minus 3y equals to 12. So yes, again you can write from here. I am writing now here, so it can be written as x equals 12 plus 3y, 12 plus 3y by 2. 12 plus 3y by 2. So which is nothing but 6 plus y by 2. No, 6 plus, sorry, 6 plus 3y by 2. So hence, again you can plot this, let's say x and y. So when y is 0, x is again 6. When y is 0, x is again 6. And when x is 0, so y will be nothing but negative 12 by 3. So here you can say when x equals to 0, when x equals to 0, y will be negative 4. Let us plot it. So 6, 0 is the same point, and 0, minus 4. So this is 0, 1, 1, 2, 3, 4. So this is, and hence the line is something like that. So clearly the point of intersection is 6, 0, because 6, 0 satisfies both. Let's check whether it is actually true. So if you put 6, 0 here, it is satisfying the first one. And if you put 6, 0, 2 into, yeah, second one, it is satisfying. So hence 6, 0 is the solution. Okay, so this is how graphically you have to solve this. Now comes this kind of, now we are solving linear equations. Now if you see, this is not a linear equation here. This is not a linear equation, Why? Because the power of x is -1 and power of y is also -1, both of them. But it can easily be transformed into linear equation. How? By assuming or substitution. Let us say u is equal to 1 upon x, and v is equal to 1 upon y. Now the moment you say that, the equations are transformed as 2u plus 2 by 3v equals 1 by 6. So after multiply the entire equation by 6 to simplify it, you will get 12u plus 4v is equal to 1. So this can be equation number 1. Secondly, in the second equation, you will get 3u plus 2v equals 0. 3u plus 2v equals 0. And then this is equation number 2. Now what can you do? You can eliminate. Now let us multiply this equation by 4. So you'll get 12u plus 8v is equal to 0. This is equation number 3. Now what you do is 1 or so you can do 1 minus 3. If you do that, u will be eliminated, and 4v minus 8v is negative 4v is equal to 1 minus 0, which is 1. So v is equal to negative 1 upon 4. Okay, and then if you put v equals to this thing, you'll get b equals to minus 1 by 4. If you put, you'll get u. But the other way could be you multiply the second one. The second equation, equation number 2. So I'm multiplying the equation number 2 by 2. So hence you will get 2 into 3u plus 2v equals 0. And this will get, you will get 6u plus 4v equals 0. This is equation number 4. Right. Now what you can do is do 1 minus 4. So this will give you 12u minus 6u is 6u, and 4v and 4v gets eliminated, and then you will get 1 minus 0 as 1. So u is equal to 1 upon 6. Right? So when v is equal to 1 minus 1 by 4, you can write, what was v? V was 1 upon y. So y is equal to 1 upon v, which is nothing but negative 4. You can say x equals to 6. V was 1 upon x. So x equals to 6. Let's check whether this is correct or not. So first one, equation number 1 will be nothing but 2 upon 6 on the LHS plus 2 by 3 into negative 4, which is equal to 2 upon 6, and then this will be this is not, this is somewhere we made a mistake. Oh, v equals to y equals to negative 4, 2 upon x. So we did some mistake somewhere, maybe, hence it is not coming. 2 upon x. So 2 upon 6 is 1 by 3, and then so it is correct, no worries. So 2 upon 6 is, this is 2 upon 6, and this is nothing but negative 2 upon 12. So which is nothing but 4 minus 2 by 12. Am I right? 4 minus 2. Sorry, this will be 2 by 12. 2 by 12. So I'm doing once again, sorry for this confusion. So it is nothing but 4 minus 2 by 12, which is 2 by 12, which is equal to 1 by 6. So which is correct. Okay, so the moment you get x, so this is correct. You can check second equation also. I am writing here. Second equation is 3 upon 6 minus 2 upon 4, which is nothing but 0. So hence solution is correct. So y is equal to minus 4 is correct, and x equals to 6 is correct. Okay, so this was the first question. Let's go to, by the way, this was a board paper question. Again, similar looking question. So here only you need to substitute 1. Y is already in form, if you see. Here 4x has to be changed. So hence you can assume u to be equal to 1 upon x, and then rewrite the equation. So it will be 4u plus 5y equals 7, and 3u plus 4y equals 5. And then again do the repeat of the process you already know. You multiply now. How do you? So I will go for elimination again. Substitution would be the last thing I would do. So what I'll do is I'll multiply 1 by this entire 1 by 3, and the equation number 2 by 4. Why? Then my coefficient of u will be same. So let us see. So this is 12u plus 15y, isn't it? 15y equals 21. So multiply by 3, 12y, 12u plus 15y plus 21. And then second is 12u plus 16y, 12u plus 16y is equal to 20. So this is equation number 3 and equation number 4. So 3 minus 4. 3 minus 4. So what will happen? 12u gets cancelled. 15y minus 16y is negative y. And this is equal to 21 minus 20 is 1. So y equals negative 1. Okay, so the moment you put y equals to 1 in any of these, so let's say 4u plus 5 into negative 1 is equal to 7. That means 4u is equal to 7 minus 5, that is 12. So u is equal to 3. That means x equals 1 upon 3. Let's check. Why? Because x equals to 1 upon u. Let's check equation number 1. We'll check. 1 is 4 upon x. So 4 upon 1 by 3 plus 5y. So 5 into negative 1 is equal to 12 minus 5, which is equal to 7. So satisfies. And equation number 2 is 3 upon x. That is 1 upon 3 plus 4 into negative 5, which is equal to 9. And I'm sorry, y is minus 1. So this is minus 1. So hence it is 9 minus 4, which is 5. So this is also true. Both are correct. So hence our solution was correct. Okay. Next. Okay. So again, the question is, what happens is the moment you see only variables, there is no numeral here, then many people actually start panicking. You should not do that. Yeah. So if you check, there is no numeral here, and many people are averse of these kind of questions. But do not afraid. Do not panic. Do not get panicked with such questions. And you know already how to solve. But be very, very careful while you are handling variables, and don't mess up with the signs. So let us see how do we do it. And we know elimination is one of the favorite mechanisms. So we'll be using that method only. So the equation number 1, this is equation number 1, and equation number 2. It always helps. If you want, you can simplify this. So hence, let's say b upon ax plus a upon by equals a square plus b square. So let us multiply the entire equation by ab. Why am I doing this? Because if you do that, then a and b gets eliminated in both the terms, in the first two terms, right? So you multiply ab. Alternatively, you can take LCM of the first two terms, denominator, and then simplify and go ahead like that. But here is how we will be doing it in this way. So multiplying the entire equation by AB, you will get b square x, because a will get cancelled, and it is a square y, and this is equal to a cube b plus a b cube. Okay, so hence you get this b square x plus a square y is equal to a cube. Okay, so a cube. So b square x plus a square y equals a cube b plus ab cube. And the second equation is x plus y is equal to ab. So what I can do is I'll adopt elimination. So hence, to equate the coefficient of x, I will multiply with b square, both the entire equation. I will get b square x plus b square y is equal to ab cube. This is my equation number 3, and this is my equation number 4. So what I'm gonna do is I will do 3 minus 4y, because x will get eliminated simply. So b square x minus b square x is 0, and hence it will give you a square y minus b square y on the LHS. And on the right hand side, ab cube and ab cube gets eliminated. You will get a cube b. Okay. So if you see, what is it? This what is it now? So y is equal to y times a square minus b square is equal to a cube b. So y equals a cube b by a cube square minus b square. Right now, to get x, do not substitute it. Rather, again, you use elimination. So how will you eliminate? So now you multiply the second equation by a square, right? So you will do a square times x plus y equals ab. So hence you will get a square x plus a square y is equal to a cube b. This is equation number 5. Okay, then how will you eliminate this? You will use 3 minus 5. So do 3 minus 5. So what will you get? Clearly a square y is getting cancelled. So hence you will get b square minus a square x is equal to, and a cube will go, so it is a b cube. So hence x equals nothing but a b cube upon b square minus a square. Okay. So these are the two solutions. What are the two solutions? One is y is equal to this. So if you have time left towards the end of the paper, let's say once you are done with the paper, your time is left, then usually it is a good practice to put a star mark, so that when you come back, you please deploy these back into equations and see, and especially if you see it is already satisfying the second equation. So most tentatively the solution is correct. The solution is correct. So hence, but yes, nevertheless, if you get time, again check your calculations. Okay, next. Second is, now we see the question is on the consistency part, right? So determine the value of k. These type of questions are there. So that following linear equations have no solution. So no solution means a1 by a2 is equal to b1 by b2 should not be equal to c1 by c2. This is the criteria for no solution. Now, so if you see, you have to first, what is a1 here? Let us jot down. A1 is 3k plus 1, right? A2 is equal to k square plus 1, right? And B1 is equal to 3, B2 is equal to k minus 2, C1 is equal to negative 2, and C2 is equal to negative 5. These are the values. Just check once. Yes, looks like it's correct. Very good. So hence, what do we know? We know A1 by A2. So 3k plus 1 by k square plus 1, k square plus 1 is equal to 3k plus b1 by b2. That means 3 upon k minus 2. And this must not be equal to minus 2 by negative 5. Right? Right? So let us solve this part first. So if you see, cross multiply, you'll get 3k plus 1 into k minus 2 is equal to 3 times k square plus 1, which is equal to 3k square minus 6k plus k minus 2 is equal to 3k square plus 3. Okay, so 3k square gets cancelled. So if you see, minus 5k is equal to, if you take a minus 5k here and then minus 2 goes on to the right hand side, you will get 5, right? So k is equal to negative 1. Okay, k is equal to negative 1 is the solution, right? So if you put k equals to 1, negative 1, then anyways, yeah, so if you put k equals to 1, negative 1, then the system doesn't have any solution. Okay, next. Now, these are the word problems which are there. So the first word problem is the sum of a 2-digit number and the number obtained by reversing the order of its digit is 165. If the digit differs by 3, find the number. So let us say, you will say what? Let us say the digits are x and y. Okay, right? So if the digits differ by 3, so let us say mod of x minus y will be equal to 3. Why am I using mod of x minus y? Because I don't know whether x is more or y is more. Okay, so mod of x minus, so hence you please keep in your mind that either x minus y is equal to 3 or y minus x is equal to 3. Both can be possible. And now let us say if my number was xy, then in actuality the number is nothing but xy is just the position, it's not a multiplication of xy. So the number will be nothing but 10x plus y. And then they're saying reverse this. So the reverse number will be yx, which will be nothing but 10y plus x. So if you add that both of them, that is 11x plus 11y, and the sum is, they are saying the sum of 2-digit number and the number obtained by reversing the order is 165. So you will get x plus y is equal to 15. Correct? X plus y is equal to 15. Now x plus y is 15, and let us say x minus y was 3. So hence add both of them together, you'll get 2x equals to 18. So x becomes 6. Correct? So hence the numbers are 96 and 36. If you add both of them, so 96 and sorry, not 36, 69. 96 and 69. So 96 plus 69. 165 is the sum. This is how you will solve this equation. Okay. Right. So what is the learning? Please remember, number, any 2-digit number is can be expressed as 10x plus y. Right. Next. So a 2-digit number is such that the product of its digit is 20. So let us again start with x and y. So let's say x and y are the digits. So the product of its digit is 20. So x, y is 20. If 9 is added to the number, the number would be nothing but, what is the number? 10x plus y is the number, right? If 9 is added to it, so 9 is added to this number, the digits interchange their places. That is, this becomes 10y plus x. Correct? Why? Because if xy was the number, not the product, the position wise, xy, so hence it is 10x plus y. And if it is yx, then it is nothing but 10y plus x. That's what they're saying. So number plus 9, the digits interchange their places. So 10y plus x. So hence what will you get? You will get 9x minus 9y plus 9 is equal to 0. Or y minus x equals to 1. If you see, y minus x equals to 1, right? This is 1. And the other equation is xy is equal to 20. So hence, if you see, this is a question which involves not only solving linear equation but also quadratic equation. How? Let us see. So hence I can say y is equal to x plus 1 from here, and then use equation number 1 and equation number 2 to solve this. So hence x times, now y is x plus 1, and this is equal to 20. So it is x square plus x minus 20 equals 0. So if you see, this is, we have got a quadratic equation. So how to solve this? Split the middle term, x square. It will be clearly 5x minus 4x minus 20 equals 0. So hence if you see, it is x times x plus 5 minus 4 times x plus 5 equals 0. So hence it becomes x plus 5 times x minus 4 equals 0. And hence either x equals to minus 5 or x equals 4. But my dear friends, x equals to minus 5 is not a feasible solution. Not a feasible solution. Or not a possible solution. Why? Because digits cannot be negative. So what is the correct solution? X equals to 4. So if x equals to 4, then you know y equals to 5. So let us check. So x equals to 4 and hence y is equal to 5 because 4 into 5 is 20. So hence the numbers are 45 and so hence if you add 9 into it, you'll get 54. The numbers, the digits reverse the order. Okay, so hence our solution is correct. Okay, so numerator denominator type. The sum of the numerator and the denominator of a fraction is 12. So let us say let the fraction be. So this is very typical problem, typical linear equation problem of CBSE board. So let the fraction be x upon y, correct? And they're saying the sum of the numerator and denominator of a fraction is 12. That means x plus y equals 12. This is equation number 1. If the denominator is increased by 3, that means y becomes y plus 3. The fraction becomes 1 by 2. So hence x upon y plus 3 equals 1 upon 2. So you have to find out x and y. So let's cross multiply. You'll get 2x equals y plus 3, right? And hence you simplify it, you will get 2x minus y is equal to 3. This is equation number 2. Then what remains to do is add 1 and 2. 1 plus 2. Why am I adding? Because if I can see there is a plus 1 as a coefficient of y, negative 1 as a coefficient of y in the second equation. Adding both, you'll get 3x, and this is equal to 15. So x barabar 5. So x is 5. When x is 5, then you know y is 7, right? So if you see 5 by 7 plus 3 is actually 1 by 2. 5 by 10 is equal to 1 by 2. So hence our solution is correct. Okay, great. Next. Okay, now distance, speed, time. Abdul traveled 300 kilometers by train and 200 kilometers by taxi. It took him 5 hours 30 minutes. But if he travels 260 kilometers by train and 240 kilometers by taxi, he takes 6 minutes longer. Find the speed of the train and that of the taxi. So whatever is required, you assume that to be the variable. So let's say speed of the train be u, okay, and speed of taxi be v. Okay, speed of the train be u, speed of the taxi be v. Now Abdul traveled 300 kilometers by train and 200 kilometers. So time taken, right? So time taken in case A. So what is case A? Time taken is nothing but, you can write the formula first. That is nothing but distance by, if velocity is constant, you can write distance by speed. This is time taken. So hence let's take the first case, right? And then please also mention this is kilometers per hour, right? So that there is no confusion in units. We'll like v kilometers per hour. Now time taken is distance upon speed. So 300 kilometers by train, that means time taken will be 300 upon u, and then 200 by kilometer by taxi, so 200 upon v. Isn't it? It took him 5 hours and 30 minutes. That means it is 5.5 hours, right? But he travels 260 kilometers by train. So 260 by u plus 240 by v. Okay, they are saying 6 minutes longer. So whatever the initial this thing was, 5.5, but 6 minutes is in minutes. So we'll have to convert it into hour, which is nothing but 6 upon 60 hours. Please be very careful. So many people will just add 6 here and they will not be able to solve it. So be very, very careful. Okay. Now, so how do we solve this? So 6 by 60 is 1 upon 10. So 0.1, this is nothing but, if you see, this is nothing but 5.6. Isn't it? 5.6. Now let us solve the equation. So hence, if you see, let us assume 1 by u is equal to x and 1 by v is equal to y. So the equations which are left is nothing but 300x plus 200y equals 5.5 and 260x plus 240y is equal to 5.6. Okay, so now what you can do is you can simplify and then use substitution also. So if you subtract these two equations together, you will get very simple relation. So subtract these two. So you'll get 40x minus 40y is equal to negative 0.1. Okay, so if you see, this is nothing but x, or you can write y minus x is equal to 0.1 by 40. I reverse the order of x and y so that I can eliminate negative sign from the right hand side, right? So hence you will get y minus x is equal to 1 by 400. Okay, now what you can do is y is equal to x plus, right? So I have to just now solve this. I'm short of space here, so I'll go and solve that in the note. So just let me just rewrite the equation. 300 by u, 200 by v. Right? So the equations are, what are the equations? So the equations are 300 upon u plus 200 upon v is equal to 5.5. And then we had 260 upon u plus 240 upon v is equal to 5.6. Okay, and then we transform these equations to 300u plus 200v, sorry, 300x plus 200y equals 5.5. And the second equation was 260x plus 240y equals to 5.6. And then let's say this is 1 and this is 2. So do 2 minus 1 and you will get 40y minus 40x is equal to 0.1, and hence I can write y minus x is equal to 0.1 by 40, which is nothing but 1 upon 400. Right? Y minus x. So y can be written as x plus 1 by 400. Okay, and then now you can use the first equation. So using the first equation, what can I say? 300 times x plus 200 times x plus 1 by 400 is equal to 5.5. Right? Substitution I'm using. So 300x plus 200x plus 200 by 400, which is half, is equal to 5.5. So hence I will get 500x is equal to 5.5 minus 0.5, because 200 by 400 is 0.5, so which is equal to 5. So hence x is equal to 5 upon 500. Okay, so x is 5 upon 500, so which is nothing but 1 upon 100. So what is then, what was u? So u is 1 upon x is equal to 100 kilometers per hour. 100 kilometers per hour. So now when x is this much, so what is y? Y is equal to 1 by 100 plus 1 by 400. because y is x plus 1 plus 400. So hence you will get 4 plus 1 by 400, isn't it? So which is nothing but 5 by 400, which is nothing but 1 upon 80. So what is v? V is 1 upon y, which is equal to 80 kilometers per hour. So these are the two speeds. One is 100 kilometers per hour, another is, so you can check if it is correct. So hence 300, first equation will check 300 by 100 is 3 and 200 by, so you'll check in this equation. 300 by 100 is 3 and 200 by 80 is 2.5. So 3 plus 2.5 is 5.5. Looks like correct. Okay. So this is again a board question. Great. Next is find the value of a for which the pair of linear equation this and this has infinitely many solutions. So you know this condition again. So for infinitely many solution, and a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Always remember, for infinitely all equal, infinitely solutions all equal, all ratios must be equal. Now, what is a1 by a2? So first of all, write the equations very carefully. So you can write 2x plus 3y, and hence it is equal to 7. So it is better idea to write all of them together, right? And the second one is 4x plus ay, 4x plus ay minus 14 equals to 0. So that means a1 by a2, 2 by 4 must be equal to 3 by a must be equal to minus 7 by minus 14. Right? That means 1 by 2 must be equal to 3 by a, and hence a is equal to 6. Right? So this is how you will solve. Okay. Now, yeah. So actually, if you see, this particular question was asked in CBSE 2018. So this is CBSE 2018 problem. Last year, this question was asked in the board exam. Okay. Next. Yeah. So this is the question. The question is the tens digit of a number is twice its units digit, and the number obtained by interchanging the digits is 36 less than the original number. Find the original number. For this is also CBSE 2018. CBSE 2018 question. Okay. So the tens digit of a number is twice its units digit. So let the digit, or you should write, let the tens digit be x, and let the units digit be y. The number obtained by interchanging the digits is 36 less than the original number. So original number is nothing but, what is the original number? 10x plus y, right? And new number after interchanging the digits. Interchanging the digits will be 10y plus x. Correct. Now what are they saying? The number obtained by int is 36 less. So the new number is 36 less. That means the original number was 10x plus y, and if you subtract 36 from it, you will get 10y plus x. Okay, and another information which was given in the very first line was the tens digit of a number is twice its units digit. So hence I know x is equal to 2y, isn't it? Tens digit of a number is twice its units digit, so x equals to 2y. And now simplifying this equation, you will get, what will you get? 9x minus 9y is equal to 36. And now put x equals to 2y, so you'll get 9 into 2y minus 9y is equal to 36. So 18y is equal to 36. So y is equal to 2. And x hence equals to 4. Right? So, am I right? 42 and 24 is not. No, something. I'm sorry. 4. This will be 4. This is 9x minus 9y is 36. So x is 2y. So 18y. Oh, this is 9y. I'm sorry. So hence this is 4, and hence it is 8. Right? So the number is 84, because if you reverse the number, it will get 48, and the difference is 36. Yes. So hence, what is the original number? Original number is, so don't write these things in your paper, because this is just for me to check. So you can check it in your rough area. So x or original number is equal to 84. Okay. So this is also CBSE 2018. So you now know the questions of linear equation will not be of that the questions will not be such that you will not be knowing it. The general problem in linear equations you need to take care is, what should you take care of? One is linear equation. You must be very careful in terms of calculation mistakes. Most of you would be losing marks because of this, right? Second, this thing is recheck the solution. Please recheck the solution. Okay, so you can by deployment of the actual value. Please check it. Okay, and third is, remember the 3 criterion. Remember criteria for consistency. Consistency means whether the solution is there or not. Remember the three cases. So A1 by A2 is not equal to B1 by B2. This is for one solution, right? Then A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. This is parallel line or inconsistent. And third is A1 by A2 is equal to B1 by B2, C1 by C2, infinitely many solution. Many solution. This is also called no solution, right? So please remember these 3. Do not get confused and do not use wrong condition. Then solve the question by the desired method or the method mentioned. These are the common errors. Do not just jump on solving this equation just after looking at the question. Okay, so you Please read the question carefully. Okay, and then very importantly, spare some time to go through the solution and check whether the obtained solution satisfy the given set of equations. Okay, so I think this is good enough for you for for the entire summary of the chapter. So I think you'll be able to solve it, and the questions will be within reach. Do not. The only thing would be that you will be making mistakes while calculation, and so do not do silly errors. Please be mindful of this, and I think you should be able to solve. Linear equations are very very low hanging fruits in your exam paper. So guys, if you have any other problem, you can post it here. Otherwise, I think you are good to go. And we will be meeting again with another set of, let's say, another topic. Okay. If you have any other question, you can please post it here. Otherwise, you can always reach out to me separately. So if you don't have any other queries, then we'll call it a day, and then we will take up new topic tomorrow. Anyone is having any problem? So thanks a lot, guys. See you then tomorrow. Thank you.